Assalamualaikum and hello to everyone. In today's video lesson, we will continue with chapter 2 of our syllabus. We will continue with subtopic 2.8, where we will look at the final two remaining air conditioning processes, which are the cooling with dehumidifying and adiabatic mixing of airstreams. Here we have the fourth air conditioning process, which involves a combination of cooling and dehumidifying process. Now, sometimes air needs to be dehumidified after a cooling process in order to decrease its water content slightly. This is done by cooling the air until it is below its dew point temperature to promote condensation. At the end of this process, the air will be cold and saturated. Saturated here means that the air will have a relative humidity of 100%. Once the air is saturated, water droplets will start to condense. The condensate temperature leaving the air is usually the same as the air temperature leaving the system. The process path for this process on a psychometric chart is shown in the figure on the right. For mass and energy balance equation, mass flow rate for dry air will remain constant. For water vapor, since moisture is removed from the air, the water vapor mass balance is as follows. Rearranging this equation allows us to calculate the mass flow rate for water vapor leaving the air. For energy balance, using the steady flow energy equation, the equation is reduced into the following equation. Rearranging this equation allows us to calculate the amount of heat removed during the process. Now, please take note of these two key points for this process. Okay, now let's look at the example for this process. Feel free to pause to read and understand the question properly. For step 1, please try to draw the schematic diagram for this process. What shall we use for this question, you might ask? Since the air pressure for this question is 180 m, we can use the psychometric chart to determine the properties of air. For step 2, to determine the mass flow rate for water vapor leaving the air, we will use the equation from the water vapor balance equation. For amount of heat removed, we will use the energy balance equation for this process. For step 3, besides reading the properties from the psychometric chart, we must first calculate the mass flow rate for dry air using the following equation. We will plot for state 1 and state 2 and read the properties of air using the psychometric chart. Now, let's look at how to plot the psychometric chart for this process. First, plot and label for state 1. Draw the process line for the cooling process until it reaches its dew point temperature and label it as X. Next, plot the temperature for state 2 and draw the process line for the dehumidifying process from X until it reaches the temperature for state 2. Next, draw the required property lines, read the properties as precise as possible, and list them down. For step 4, substitute and solve for the question. If there are any questions, please do not forget to ask me later in our discussion session. The fifth and final air conditioning process for this subtopic is the adiabatic mixing of air streams. Adiabatic mixing of air streams usually occurs in large air conditioning systems used in shopping complexes, hospitals, and etc. Mixing of air streams is important to improve the quality of air supplied in the air conditioning system. It involves the mixing of return air RA and outside air OA, which will result in supply air SA. The schematic diagram and the process path on the psychometric chart is shown in the figure below. For mass and energy balance equation, for dry air and water vapor, since mixing is involved, the equations are based on the conservation of mass principle, which states that mass entering the system must be equal to the mass leaving the system. For energy balance, from the general SFEE, the equation is reduced to as shown in the slide. Now, we can combine all three equations by eliminating m.A3. By doing this, we can get the ratio equation, and this equation can be used to find either the specific humidity or the specific enthalpy at state 3. Now, let's look at the example for this process. Feel free to pause to read and understand the question properly. For step 1, please try to draw the schematic diagram for this process. Now, since the air pressure for this question is 180 m, we can use the psychometric chart to determine the properties of air later. For step 2, to determine the specific humidity at state 3, we will use the ratio equation from the previous slide. For relative humidity and dry bulb temperature, we will plot and read the values from the psychometric chart for state 3, and we can solve the volume flow rate using the following equation. For step 3, using the chart, we can plot for state 1 and state 2 using the given information. For state 3, once we have calculated for omega 3, we will draw the required property line. Now, let's look on how to use the psychometric chart for this process. First, plot and label for state 1 and state 2. Next, draw the connecting process line for both of the states. Read the values for specific humidity at state 1 and state 2. Don't forget to read for specific volume and specific volume at state 1 and state 2. Now, using the ratio equation, we can calculate for specific humidity at state 3. In the psychometric chart, locate where omega 3 is at and draw the property line until it intersects with the process line for state 1 and state 2 previously. This intersecting point is labeled as state 3. Do not forget to list down all the properties for state 1 and state 2. Now, From state 3, draw the property line for relative humidity and also draw the property line for dry bulb temperature at state 3. Do not forget to read for specific volume because it is required to calculate the volume flow rate later. List down the properties for state 3 and for step 4, substitute and solve for the question. Okay then, we have come to the end of this video lesson and also completed chapter 2. For exercises, please refer to the original notes. Please do not hesitate to ask if there are any questions. Thank you for your attention and have a good day.